The length of a rectangle is 5 times its width. When the length is decreased by 3 meters and the width is increased by 2 meters, the area of the new rectangle is 60 square meters. Find the original length and width. Now remember, or when we read this carefully, we're looking at essentially two rectangles, the original rectangle and the increased rectangle. So we have to keep those straight as we're working through the problem. We begin by familiarizing ourselves with the situation. Since we're asked to find the length and width of the original rectangle, we will let W equal the width of the original rectangle. And then we'll make all the other things that we look at in terms of W. So then 5W is the length of the original rectangle. And then the width of the new rectangle would be W plus 2. And the length of the new rectangle would be 5W minus 3. Now this takes a while to write out, but now I'm very clear of what each thing represents, and it'll make the translating step much easier. To translate, we'll use the formula for the area of a rectangle. Now the area of a rectangle equals length times width. We're given the area of the new rectangle would be 60. And so I want to use the length of the new rectangle, which if I look back here, the length of the new rectangle was 5W minus 3, and the width of the new rectangle was W plus 2. So I use 5W minus 3 for the length and W plus 2 for the width. And now I can solve this equation. I have first multiplying this out, I have 60 equals 5W squared plus 7W minus 6. Then I need to get a 0 on one side, so I subtract 60 from both sides, and I have 0 equals 5W squared plus 7W minus 66. And then I factor. 0 equals, this factors to 5W plus 22, W minus 3. So I can say that 5W plus 22 equals 0, or W minus 3 equals 0. Subtracting 22, I have 5W equals negative 22, or W equals negative 22 fifths. Or solving here, adding 3 to both sides, I have W equals 3. So I have two possibilities for W, negative 22 fifths or 3. Now when I check the answer, I'm going to go back to my original problem. And when I go back to the original problem, I realize that W stands for the width of the rectangle. The width cannot be negative, so negative 22 fifths cannot be a solution. So I'm only going to check W equals 3. Then the length of the new rectangle would be, the length of the old rectangle would be 5W, which is 5 times 3, which is 15. The width of the new rectangle would be W plus 2, or 5. And the length of the new rectangle would be 5W minus 3, or 15 minus 3, or 12. So this is the original rectangle length and width. This is the new rectangle length and width. The area of the new rectangle would be 5 width times length, 12, or 60, which is what we were given. So we can state then, and we're asked for the original length and width. So the original width is 3, the original length is 15. So I state that the original length is 15 meters and the original width is 3 meters.